Hello students, let us discuss the particle nature of electromagnetic radiation. In that we are going to discuss photoelectric effect. In 1887, H. Hertz performed a very interesting experiment. Let us discuss this experiment. He observed that when a light of suitable frequency strikes on the metal surface, then some of the electrons get ejected. These electrons are called as photoelectrons. If h nu is the energy associated with the incident radiation, from this some of the energy is used up to eject the electrons, and the rest of the energy will be given to eject the electrons in the form of kinetic energy. The phenomena of ejection of electron from the surface of metal when a light of suitable frequency strikes in it is called as photoelectric effect, and the emitted, or we can say ejected, electrons are called as photoelectrons. But it is observed that all sort of light will not emit the electrons. As shown in the figure, when the light of frequency which belongs to red color does not emit the radiation, and the green light also does not emit the radiation, but the blue light is, when it strikes on the metal surface, it ejects the electrons. That means for each metal, certain minimum frequency of light is needed to eject the electron. This frequency is called as threshold frequency. According to Einstein, when a photon with energy E is equal to h nu strikes on the metal surface, then from some of its energy is used up. That is, energy E naught is used up to eject the electrons from the metal atom, and the remaining energy is given to eject the electron in the form of kinetic energy. This may be expressed as energy of a striking photon, that means the energy of incident light, that means a photon, is equal to binding energy, that means the amount of energy utilized to eject the electron, plus kinetic energy of the ejected electron. So we can write the equation as, that is, E is equal to, energy of the photon is equal to E naught, that means the energy utilized to eject the electron, plus kinetic energy. So when we substitute the value, E is equal to h nu is equal to E naught is equal to h nu naught plus kinetic energy, that is half mv square. So we get the formula, that is h nu is equal to h nu 0 plus kinetic energy. Here where h nu is the energy of the photon, that is incident photon, and h nu 0 is the binding energy, that means the energy utilized in order to eject the electron, and the rest of the energy will be as kinetic energy. So in this we can say that the nu naught, that is the threshold frequency. So if the incident light, its energy is greater than the energy required for the ejection, then only the ejection takes place. That means if nu naught, if nu is greater than nu naught, then only the ejection takes place. Otherwise the ejection does not take place. That's why it is called as only ejection takes place when a light of suitable frequency strikes on it. Suitable means the incident light having the photons must have a frequency greater than threshold frequency. Then only we can say that ejection of electron takes place. So we can say that nu naught should be less than nu. That means the incident photon should have the frequency greater than the threshold frequency. Then only the ejection of electron takes place. Only few metals such as cesium, rubidium or potassium, in which electrons are loosely held by the nucleus, show photoelectric effect. That means photoelectric effect is shown by only certain metals like cesium, rubidium, potassium. These are the elements of first group in the periodic table. These have a single electron in the valence shell that is loosely attracted by the nucleus, so that can be easily ejected when the light of suitable frequency strikes on it. So we can say that only these elements can show photoelectric effect. The kinetic energy of ejected electron is directly proportional to the frequency of incident radiation but independent of its intensity. And the number of electrons ejected, that means the photoelectrons, is proportional to the intensity or brightness of the light. That means kinetic energy is independent of intensity, but number of electron is dependent upon the intensity. The apparatus showing photoelectric effect is shown in the figure here. It consists of a vacuum chamber in which two electrodes are there. One is a positively charged electron, the other one is negatively charged electron, which is connected to the external circuit. Now, the metal like rubidium, cesium or potassium is taken in the negatively charged electrode. So when the light of suitable frequency strikes on the metal surface, it starts to eject the electron. These electron, because being negatively charged, it moves toward the opposite charged electrode, that is positively charged electrode. So there will be a flow of current through the circuit. So from this it was concluded that after striking the radiation, that is a light, suitable radiation to the metal surface, it ejected the electrons and this effect is called as photoelectric effect. So from this we conclude photoelectric effect. It is a phenomena of ejection of electron from the surface of metal when a light of suitable frequency strikes on it. This effect is called as photoelectric effect. And the ejected electron is called as photoelectron. So in this we learned the points that when a beam of light falls on a metal surface, electrons are ejected. Second point, number of electrons ejected is proportional to the intensity, and the threshold frequency for each metal there is a minimum frequency below which photoelectric effect is not observed. This frequency is threshold frequency. And if the frequency of the light is less than the threshold frequency, then there is no ejection of electron, no matter how long it falls on the surface or how high its intensity. So the photoelectric effect, this is all we have discussed here. From this we come up with a formula, that is H nu minus H nu 0 is equal to half mv square. So this is all we have discussed in the photoelectric effect. Rest of the portions will be discussed in the next video. and also the problem related to this will be discussed in the next video. Thank you everyone.